In this video, we're going to introduce exponents using the powers of 10. Powers of 10 are useful for scientific notation, which is used to describe orders of magnitude. In the left-hand column, we have the expression, which is given as a power of 10. In the center column, we have the expanded form, which is going to be doing the multiplication by hand. And finally, in the right-hand column, we have the value, which will be the exact amount. For 10 raised to the fifth power, we multiply 10 by itself 5 times, giving us 10 times 10 times 10 times 10 times 10. The value of this is 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. And 10,000 times 10 is 100,000. Notice that we have 1, 2, 3, 4, 5 zeros with the 1 as the sixth unit. We'll circle back to that in a minute. For 10 to the 4, we have 10 times 10 times 10 times 10. 4 tens. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Note that we have 4 zeros in this case. For 10 to the 3, we'll have 3 tens and 3 zeros. 10 to the 2, much the same, 2 tens and only 2 zeros. 10 to the 1 is just 10 because we only have 1 10, and so the value is 10. 10 to the 0 requires the identity for exponentiation to 0. Any number raised to 0 is 1. And so the value is itself 1. Now, we get into negative exponents. This is the reciprocal. So this is the same thing as 1 divided by 10. And so we have 0.1. Notice that we have now 1 leading 0 to the left of the decimal. In 10 to the minus 2, this is the same thing as 1 divided by 10 squared, which, as we see up here, was 10 times 10. So we have 1 divided by 10 times 10, which is 1 over 100. 1 over 100 is 1/100th. Note that we now have 2 leading zeros. 10 to the minus 3, much the same. I'm going to expand this out using the other division symbol. And now we have 3 tens. 10 to the minus 4, we'll have 4 tens and 4 zeros in the value. And 10 to the minus 5, finally, 5 tens and 5 zeros. In scientific notation, we write things as some number times some power of 10. In the case of scientific notation, we think of it as moving the decimal point left or right depending on the exponent in the power of 10. So we start with 1.0, and because it's a positive power of 10, we want to move 5 decimal points to the right, giving us 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. If I write in these zeros now, you'll see that I end up with 100,000, which is the value we got for 10 to the 5. If I do this for 1 times 10 to the minus 5 now, we have 1.0. And now instead of moving to the right, this negative sign tells us we're going to move to the left. So we move 1, 2, 3, 4, 5 units to the left with the decimal point. And that gives us 0.00001, which is the answer we got for 10 to the minus 5.